the former lead of the Truffle suite, now the lead of the Ethdebug working group and also the author of ABI to Solve. And he will introduce Ethdebug, a debugging format for smart contracts. Please welcome him on stage.
Merhaba, gnidan. Thank you for being here. I appreciate the size of the audience at this time of day. For those of you at Rave last night, if you want to fall asleep through the second half of my talk, I've prepared a summary slide that covers most of it. Basically, there are no good debuggers for EVM languages. And if you want to make a debugger for an EVM language, you have to spend a lot of money and you still won't have a good debugger. To make matters worse, the compilers know information that would make a good debugger, inherent to the process of being a compiler, right? Like compilers have to keep track of when structs go on the stack, what that struct was, where it was defined, all of the stuff that you would want to know if you're looking for a bug. And so, unfortunately, compilers don't output that today, in part because actually encapsulating that information and designing a format that is sufficient for debugging is not it's not trivial to do that. So after 5 years of my talking about this problem, Solidity is now sponsoring my work on it, which I'm really excited about. And basically our goal is to build a standard language or a standard format for EVM languages to use, not only Solidity, that would allow it to not be very expensive to make a good debugger. Like it should be pretty cheap. I was leading Truffle for a time, 5 years. I built Truffle, or I architected Truffle Debugger originally in Truffle Codec, which is the decoding part of Truffle Debugger. And I mean, talk about expensive. I think we probably spent about $2 million, and it was merely a decent debugger. I've been shouting about how we need debugging data formats for about, well, since Prague, and maybe you all are convinced. So for the rest of the talk, I'll get into some more details. How do you make a debugger? Why it won't be good? What am I talking about? And then what have we been doing? And then I'm going to ask you all to help. So what goes into a debugger? Well, Solidity debugging, SolC fortunately provides some essential information. Like it wouldn't be possible to build a debugger at all without source maps and ASTs. So source maps, you think of Solidity produces bytecode, or any compiler produces bytecode, and that bytecode is, you could think of it as an array of instructions. The source maps are one-to-one, correspond with the instruction, and map back to the original source range. So if you have a push 4, you can see, oh, that came from this assignment. And then the ASTs, the abstract syntax trees that are produced by the compiler if you ask for it, they contain additional semantic information, like here's a struct. It has this type, right? This line is a variable declaration, this line is a function call, et cetera, right? And so what you can do is you can take the source map, look at the bytecode, see the instruction, find the source range, dig through the AST, find the node that corresponds to that source range, and then realize that you have just done a variable allocation, and then you keep track of that inside your debugger, right? And then you kind of guess at a bunch of other stuff. Also note that we have Solidity gives storage layout, but it doesn't contain actual slot information. It contains enough information that you could derive the slots, but it's not quite so easy. And yeah, basically, building a debugger requires you to kind of know the internals of the compiler. And I'll go over kind of like what we can know, right? We have the source maps, we have the storage layout, we can get the source ranges from the instructions, and we can get the AST node from the instructions. But we can't, without guessing, we can't know what function we're in. We can't really know what the call stack is. We don't know what variables are in scope. We don't know which variables are which on stack. I don't need to read this whole list, do I? You get the idea. It's kind of a pain. And yeah, there's a lot of guesswork, and like Truffle Debugger, we spent a lot of time building it. Tenderly as a debugger, Remix as a debugger. These debuggers have been built by looking at how Solidity works at the bytecode level and then being like, well, I think it probably works like this all the time. But, you know, you want to change the Solidity compiler, and that's going to break absolutely everything. So that's not really great. So, yeah, I mean, there's a thing that solves this problem. It's called a debugging data format. They have existed since the 80s. The compilers output them, and debuggers read them. And that's pretty cool. So what happens, like what does it look like? Well, you have, the compiler produces some output that captures the programmer intent, right? Like when the compiler produces the bytecode, it can keep track of all of the type definitions and all of the function calls and all of that. And that's what the programmer wrote. That's what you wrote if you're debugging your own code. And so debugging data format allows you essentially to map, like if you are looking at the machine and you're looking at the debugging data format, you can map from the machine state back to the high level. So kind of the opposite of what the compiler does in a dynamic way, right? Like a compiler is this like static thing, but you're looking at the machine. You want to understand what's going on in the machine. You need additional information. You need the debug symbols. Fortunately, this is like part of what compilers do. They just need to output it. And then you go from pushes and jumps to function calls, etc. So there are existing data formats for debugging, but they won't work on the EVM. Like for one, Dwarf. So Dwarf's the biggest, most common debugging data format right now. I think it's on version 4 or whatever. It expects like compilers to put the debug symbols directly in the bytecode. I do not think any one of you wants debug data on mainnet. So not the same paradigm, right? I don't think there are any 256-bit physical computers in the world today, maybe. And certainly these existing debugging data formats do not have any concept of the code that is running having its own money. So yeah, that won't work. And then Solidity kind of makes it worse. Well, because Solidity has to make it worse, right? We're dealing with the EVM, we're dealing with gas costs, so there's a number of choices that have been made over the years that make things quite interesting. Like, you store some struct or some like array in storage, and you would expect all of the bytes for that piece of data to be next to each other. No, they're like so cryptographically non-sequential, right? Yeah. Did you know that, and there's like weird restrictions, like you can have circular references in memory and only in memory. You can't have circular references in storage. You can't have it in call data. It's like weird restrictions. And then, okay, so you have some data in call data and you want it in memory. Well, it very well could have a different encoding entirely based on the location, and that's not really a thing you see all that often in computers. And then my favorite one is that the encoding strategy for the same type in the same location could be drastically different based on the length of the data. And here's an example of that. Strings that are smaller than a word fit into one slot, and strings that are shorter than a word fit into the one slot. Longer than a word, you have to go somewhere completely different to actually find the string. Neat, huh? Right? So we have this working group now, the Ethdebug format working group. We've been tasked back in DevCon at Bogota. The Solci tooling group met, and we decided that we do in fact need to solve this problem probably by January of 2023. And we started having these bi-weekly meetings, and everyone has had day jobs, and so we've made some progress, but not sufficient progress. Like we have a pretty solid list to start of known challenges. We kind of know the direction we're taking with this, and I feel ready to write a bunch of JSON schemas, so that's pretty cool. And you can see the people that have contributed to date. We have John from Certora, of course, Daniel and Camille from Solidity, and then Harry Amal from Truffle, and Marco, whom I haven't met in person yet, but I'm looking forward to, has been helping out a lot. You can follow along with our work at the GitHub repo. You can chat with us in Matrix Chat. But I'll go over a little bit of our approach as we understand it now. Like, we think we need, at a high level, kind of two distinct schemas. We need a way to describe all of the types, either the native types supported by a high-level language or the user-defined types like structs and whatnot. And then we also need a schema for kind of similar to the source mappings that I was describing, where you should be able to go from an instruction and relate that back to like the high-level model of the program, the smart contract, right? So like you should be able to see, oh, it is at this instruction that we have allocated a variable. It is at this instruction that we have gone into a new function. We also want to take the approach of versioning this format. We don't want to get it complete and like really like specific and pedantic in a version 1. We want to have something that works, and we think we can do that with things like, well, this string is encoded using the Solidity way of encoding strings, right? Like that's probably fine, right? For now. It'd be cool if we could do better than that, but it seems like a reasonable concession for now that we could just have that. This next one's really quite interesting, right? Like with all of the optimizer work that you're going to be hearing about today, it would be nice if compilers could deduplicate bytecode. So the same bytecode might refer to 1 or 2 or 3 or n different possible worlds. Like, oh, this is allocating an array of uints. This is allocating an array of bytes, right? It might be the same bytecode, but that bytecode could refer to 2 different pieces of the source or 2 different operations in like the programmer's head. So we want to account for that kind of non-determinism in this format. And then, like non-functionally speaking, we want to not make the compiler output bigger than it already is. I mean, it's unavoidable, but we want to do our best to minimize. And then, if we can avoid reinventing like source maps and ASD formats, I mean, we're going to try and do that as best we can. Like we really want to fill a gap here about what data is missing that the compilers could provide, and what would that data look like. We are also continuing to actively solicit requirements, right? Like everything, if any of you are analyzing Solidity bytecode, it's going to break via IR. Well, no, just wait for Nicola's talk. But yeah, please, we would love to hear if you have requirements or, have interest in contributing in any way. So it's really exciting stuff, building schemas. So we invite you to participate. We're doing a workshop immediately following lunch where I hope to solicit additional requirements or just chat about our approach and show you what we have so far. If you want to watch the repo, that's what it is. You can read our work in progress docs, and we have bi-weekly calls. We'd love to see you all there. And as soon as I get home, I'm going to be writing a bunch of JSON schemas, so stay tuned for those. That's all I got.
Okay, thank you, gnidan. We are running ahead of schedule now.
Yeah, I talked slower when I practiced, I swear.
Yeah, no worries. Do you guys have any questions for him? Maybe we can... Yes, there's one. Okay, great.
I noticed that you had a comment there about things like strategy solidity and strategy Viper. It would seem that if you're writing a debugger, for example, you're going to have to code for those, so you're going to have to know what they are. And that makes it more difficult, therefore, if a new language comes along, to get that adopted, because not only does it have to then be defined in the debugging format, but it also has to be adopted by every debugger that is using that debugging format. I would contrast that to something that is parametric, which has some kind of operational semantics that would mean that you weren't tied to Solidity or Viper. So I wonder if you could maybe talk to that point.
Yeah, certainly. That's really good. I would love to avoid having that. Let me, oh, I don't have my slides anymore. But if you remember like the string example, right, where it had the offset, like I would imagine that these representations would be parametric. It's a bit of a concession, right? Like how would you express abstractly, if the string is shorter than the word, look for the length in the normal storage slot. If it's longer than the word, you'll see that, and then you have to hash it, right? But that logic can be coded for a debugger in one place, and that's already an improvement upon the world today where at runtime the debugger has to know to look for a string, whereas like if the debugger says, okay, or if the debug format says this is a string encoding, you probably have a function for this implemented. But yeah, my hope is that the work for this initial version of the format would not last forever. Like, hopefully it can like help us bootstrap good debugging tooling, and then we can build on top of that. Although if you do want to come to our bi-weekly calls and repeat your point maybe every 2 weeks until we change our minds, that would probably work.
Yeah, I understand exactly what you're talking about there. I'm just thinking about the idea of embedding something like Solidity, because these things that you do is good enough for now, as experience has shown, end up being the roadblocks for later. And I'd suggest that something like what WASM was doing with their type modelling might be a solution there. But I get your point about joining the calls and hassling you.
Yeah, I might come find you to hear about that approach. Yeah, it's not ideal. I recognize that. I think we all recognize that.
Any other questions?
I mean, if there are no questions, I would add to that point. You can think of these annotations like this is the schema of Solidity as a pointer to an upcoming new document that would then have that formulated in kind of an operational semantics. So it's thought of as being extensible in that manner. For now, we use string markers for some to-be-defined details. So at least it's already been a thought. That's how we imagine it for the time being.
Okay, if there is nothing else, I would like to thank gnidan. Make sure to check out the workshop at 1:25, directly after lunch, in this room if you are building a tool and if you're interested in contributing to the Ethdebug working group. Big round of applause. Thank you.
Thanks, everyone.